Thank you all for joining us today from AFC. And today our whole focus will be making you AFC minded and to understand the collaboration that exists currently with Support Pro and AFC. So we will start out the day just giving you a general overview of AFC, and then you will have a chance to look at our website and understand the technical components of our products. We will have different kinds of training for you in terms of heat sealing and belt repair. Please feel free to ask questions. However, we do have ask questions throughout, but we will have question and answer sessions at the end of today. There will be an evaluation, and that will be a paper and pen test, but we will be going over all the answers. So when you leave today, you will thoroughly have an understanding of the content. All right. So my name's Colleen Corniss. I am the Midwest Sales Manager for AFC. I do have my team members joining me today. I have Mandy Parks, and she is our Director of Customer Relations. And we have Chris Thomas from our marketing department, and we have Mark Gutzmer from R&D, and also Ed Kennedy from R&D. So a comprehensive team is at your fingertips and your disposal to ask questions. So anyway, so we'll get started with a little bit about who AFC is. We are the provider of high temp and non-stick solutions. I like customers to think of us in threes. So non-stick, high temp, and also cold temps. So that's an easy way to remember AFC. If you have any applications that need those three that warrant high temp, low temp, or non-stick, please see us. All right, so we are the global provider of PTFE and silicone-coated composite materials. We opened up in 1988. Bill Lewis is the founder. This is a family-run company. It still is a family-run company. Bill is still present. However, his son, Chris Lewis, has taken over as president of AFC. And it's a short ride from here, so we do spend a lot of time at RPAC and Support Pro, and we've spent how many years developing this relationship, Mandy? Because you started the relationship with them.
Over 18 years. 20, I would say.
Right. And we also have joint ventures in the UK, Italy, and Mexico. We have DuraFabrics tapes, DuraChef, Chef-Pak, and No Waste Technology. So there are two different divisions within AFC. We have our industrial side, and then we have our FPG group, which is our food products group. So you obviously will be dealing mostly in industrial. However, you never know what you're going to see out in the field. So we're going to explain a little bit about both today. So these are the markets that we serve. Obviously, packaging is huge for Support Pro, but we touch many other markets as well. I think in each market, AFC can say they have a differentiator that separates them from their competition. Vinyl windows, we're in the process of developing a new product there. Certainly in canning, we have differentiating factors, but what we like to think about AFC, what's most important to us is the relationship that we have with you and the collaboration and the features and benefits of our product are definitely secondary to us. So these are our industrial products, the fabrics, the belting, the pressure-sensitive adhesive tapes, and the heat sealers. All of these you will be exposed to today. So you have booklets in your bags that show you the samples of the fabrics and the tapes that we have at AFC. So these are the different fabrics: DuraFab, DuraFlow, DuraSil, Duratec, and Duralam. So those will all be in your booklets. So the belting Obviously, we offer a different variety of splices, and we have some of those that we will be showing you today. Ed will be going over the different splices and the different edge reinforcements and guiding and tracking. There are good, better, best options in all of those arenas. It really depends on the application and the customer needs. So, and these are the Durastick tapes. So I'm not going to read all of these. I don't want to bore all of you. So those are the Durastick tapes. And then the heat sealers, we'll be doing the heat sealing training for you later on during our session today. And Ed and Mark Gutzmer will be running that. So just out of curiosity, do you do a lot of heat seal, or do you run into a lot of applications that require that out in the field?
Silicone fabrics. You want more information on that. So you'll go to our industrial fabrics section, scroll down, and then you can see we have all of our product categories with pictures and descriptions. So we'll go down to silicone, for example, since that's relevant to what we're dealing with here. And then you'll see we provide brief descriptions as to what the product is, some of the features. We've also added a very easy to use product data table. So if you want to look at specific information for, say, the 315, you can go ahead and all the general information is here available to you guys anytime you need it. And then if you actually need to give someone a data sheet or download it for yourself, those are built into the site as well. So it's very easy to find information, find what you're looking for. And again, anytime you're looking for information or need further support from us, we're available, ready, and willing to help you guys.
My name's Ed Kennedy. I'm part of the R&D team. Do a lot of special projects, do a lot of development projects, one of which that Mandy mentioned was this new sealer that would seal the bottom of the package, so the the belt actually gets hot and seals the film on the underside. I do projects like that, and I do a lot of tech support to the field sales. I've got some cards for you guys if I'm available to call for pretty much anything in the Teflon area. Let me mention a couple of real basic things that we start off every technical training with. First of all, we might have been saying Teflon along the way. What we really want to say is PTFE. PTFE is a generic name for Teflon. Technically, we don't sell Teflon because Teflon is a DuPont trademark. Even though we buy Teflon from DuPont, we make our products sometimes with DuPont, we don't pay them the extra to use their marketing trademark. So technically, we can't put the word Teflon in our brochures. You can use it verbally to say, Teflon and PTFE are the same, and they are, but we just can't market it with that name. All right, we mentioned where to use this stuff: high temperature, low temperature, and non-stick. And certainly non-stick is, I'm going to say, 98% of what we're doing with you guys, because packaging is almost entirely about melted plastic film. And when you're melting it, you're sealing it, you need to be up against a PTFE surface. And in this case, it could be a belt, it could be a piece of tape, could just be a piece of fabric. But in any case, the surface is PTFE, and so the melted plastic doesn't stick to it. What we're showing you here is the absolute basic, simple Teflon PTFE belt repairs. This type of material, I want each of you to do this as long as the iron's hot enough here, and it might not be. I got unplugged twice over there by somebody. So this is just a typical open mesh conveyor belt material, and let's say we have a hole in it. Okay, I'm going to make a little hole. If you got a hole that you need to reinforce, we're going to put a patch on here. This is Teflon PTFE coated Kevlar, and this is a bonding film. You need to do a heat sealed patch. You need three things. You need a bonding film. You need a high temperature tool. And 700 minimum. Minimum 700. Yeah. This. Yeah. And this is not going to quite get there, so we're going to simulate this. but we have a video online that's available that shows you how to do all of this.
Okay.
So the main thing here, what I've done here, I put a dot tack right there. I have a piece of bonding film, and here's my patch, okay? And what I'm going to do is I put one dot tack there. I'll have you guys each do this once. All right, so it's just temporarily held together. And now what I want to see this bonding film sticking out.
Overall, how would you describe today's training session?
I think today's training session was very well put together. It was thought out very well. The amount of information was good. It was not overwhelming, but it was a good amount of information to see possible applications that we can tie this into in the future for other projects. And the hands-on was outstanding. It was great to actually get to physically patch belts and things with the actual tools to see it work. So it was very good.
Perfect. And what would you say specifically was your favorite part of today?
Definitely the hands-on. It's, class stuff, PowerPoints and stuff. It's good information, but it's hard to retain. So actually getting to get hands-on and ask questions as you're working with tools is a very good way to learn.
Okay.
So
And this was your first experience with AFC, right?
yes.
How was the introduction?
Absolutely wonderful. I got to know everyone's name real quick. Everyone was very personable. Everyone's very friendly. So it was very good getting going.
You say you're looking forward then to the partnership moving forward with AFC and Support Pro?
Absolutely. I will definitely keep my eyes wide open for anything I can see for possible projects that we can work together on in the future. It's going to be good, I think. So.
I think that's more than sufficient. All right,
Are you go?
All right, so overall, how would you describe today's experience?
Oh, I appreciated you guys coming out and introducing yourself and showing us the product line. It was well put together.
Sure. And what would you say was your favorite part today specifically from the presentation?
I liked going down and taking a look at the belting repair part of the training that we were able to do hands-on. Oftentimes you get training and you see videos, and until you apply it, you don't really understand it as well.
Absolutely.
So that was very good part of the training.
All right, and then I guess with AFC as your partner now, do you feel that we'll be able to support your needs in the field?
Yes, I identified a need down there, talking about having maybe a roll of belting material on the van and the tools to make a belt on site, with the customer. Impulse buying, I think, it really works in our industry. When someone's down because their belt is falling apart and they have to wait 2 weeks, when I can make them one, on the spot,
Sure.
I think there's.
So it's
There's
safe to
quite
say
a
that you're
value.
excited for this partnership moving
Sure.
forward and the value we can provide to each other.
Absolutely.
Okay, great. I think that's good too. All right, excellent. All right, Steve, what led you to schedule today's training with AFC?
We had several of our field technicians that come in for training at different times during the year. This is a good opportunity because we had some other suppliers come in. AFC's gold supplier of our pack, so it was good timing to come in and teach them a little bit about what you can provide for us.
Absolutely, and can you comment a little bit about the content of today's presentation, the format?
Very good. It gave a good overall, what AFC can provide us. From our field technicians, they like to see applications and see where they could use some of the products you provide. So.
Absolutely, and then moving forward, can you describe a little bit the relationship with Support Pro and AFC and kind of the direction we're moving?
Well, being a supplier of service on machines, part of our philosophy is eyes wide open, and that means when the tech's on site, they may be working on our equipment, but we support like 120 different models of machines. So that could be machines that you put some of your parts and belts and tapes on machines. So we can keep our eyes ready see if there's applications or replacement possibilities. So that's how Support Pro would work with AFC.
Excellent, excellent.
Yeah.
And then as a supervisor, would you recommend this service to other companies and why?
Yeah, I mean, you and RPAC, AFC and RPAC has worked very well together over the years, so we definitely recommend if somebody has an application that maybe we don't want to get involved in, we would recommend, you know, going direct to you so that maybe you can get your applications guy working on a solution for them.
Perfect. I think that's more than sufficient. All right.
Thank you very much for the invitation. So this is the plan. I'm going to go over a little bit the theory behind the history of natural sciences and deep learning. A few words on theoretical aspects of deep learning, and then I'll show you some applications in physics, chemistry, and biology. So natural sciences, you are very familiar with this kind of images, but this is the beginning of natural sciences shortly after the Renaissance with people like Galileo, who built one of the first telescopes with a magnification factor of 20x. At the time, there were, of course, no computers. All the data came straight through his eye and through his brain. He had no tools really for storing data long-term and analyzing data using proper statistical or machine learning methods. And you see the same things across all the natural sciences. This is for biology, the invention of the microscopes in Holland, pretty much useless. And this is essentially what deep learning is. It's just linear regression on steroid, where you're dealing with nonlinear objects, nonlinear surfaces, and you're trying to fit those surfaces, right, using these neural networks. And again, an example into the dimension in the upper right corner, where you're trying to fit a nonlinear curve. You could use Gaussian processes, of course, or neural networks or other things, but it's nonlinear. You can still see things because it's in 2 dimensions. But if you want to go to cases where you have 1 billion of data points in 1 million dimensional space, which is what you have with images, for instance, then of course things are not become very opaque.
Control those systematics?
Control them, it's a difficult question, but you can certainly get a sense of what is the uncertainty on your prediction by having, a all-out data set on which you know what the answers are, and you have the labels, and you test the performance on that data set, and there you get a sense of the level of uncertainty in the system.
So it basically goes back to the uncertainty associated with your training data set?
Yes.
Okay.
So any modeling is part art, part science. And how much the result of a machine learning study depends on the expertise and intuition of the user. For example, you mentioned an optimal number of hidden layers. How do you select that? What happens if you deviate from that?
Right. So, there is a number of general principles that have been emerging, or general techniques. For instance, for images, it's very natural to use convolutional neural networks. I showed you the inner and outer approach as some kind of guideline for building recursive system that can deal with data of variable size. So there are all kinds of principles and rules, but there is nothing that tells you this is the best architecture, right? And a lot of it requires some tinkering or trial and error or so-called hyperparameter optimization, and there is no common solution, no agreed solution on the best way to do that. There is some hand and crafting involved, and it's a little bit inevitable, I think. And yes, so experience with training this system is certainly a helpful skill. On the other hand, there is all kinds of software and libraries and tools that make the task much easier today than it was, say, 20 years ago. So if you use TensorFlow, you use things like Keras. Those are tools that allow you very rapidly to adopt and deploy these techniques.
Could you network, we should create other successful neural networks.
Yes, I can think of that.
Hi. Does anyone, say, take a neural network and model the brain and try to correlate the number of layers in the neural network with something like types of synapses or something
Absolutely.
like that?
There is a whole literature on that. In particular, in the visual system, people have shown that if you build a visual system, let's say, using these artificial neurons, but which has the same number of layers roughly as you have in the biological case, etc., you end up observing in the artificial system a lot of the characteristics that are in the biological system. You find the same receptive fields, etc., etc. So a lot of that has been done, yes.
In the brain, what are the mechanisms that it uses to do the feedback?
Well, we know that there is a lot of feedback connections in the brain, right? That is well documented. But we don't know, for instance, which feedback connections are carrying an arrow signals versus other types of information, because there's the word feedback is very ambiguous. For instance,
but you're saying basically there are, well, no, let you keep going.
There is a physical pathway, a series of axons that goes essentially from the output level, from the motor level, or from the input level, all the way down to a synapse. There's actually many such pathways. Which one are used for learning, that we don't know. That is still things that neuroscience has to sort out. But the channels are there, that's for sure.